Welcome to SMARS Fan Live. I'm your host Kevin McAleer, and today we'll be looking at creating the tracks for the SMARS robot in Fusion 360. So SMARS is an amazing low-cost open source 3D printable robot that you can print yourself, and it's very easy to assemble, doesn't really require very much electronic skills or programming skills, and there's lots of code and versions out there that you can try yourself. So today we're going to be looking at these mechanical tracks that make it very easy to sort of go over different terrains. It sort of comes in a few different varieties. Using the same number of tracks, you can have one on each wheel, or you can have it in the sort of caterpillar track formation. So the caterpillar tracks themselves are made up of these small individual sections. Let me just get that on the screen. There we go. So each one of these, there's 32 in total, 16 for each side, and you just use the filament sort of 1.75 diameter filament as the sort of pivot. So very nice and easy to create these. Okay, let's head over to Fusion. Let's save this file and call it tracks, and let's get started. So what I'm going to do as well, I'll just bring you across smarsfan.com. We go to the Learn and Design Studio, and we look at the tracks section here. You can see a link to today's live stream, and you can also see on there some of the information that we've got. So one of the things I've pointed out on here in this sort of blue section is one of the challenges with the tracks is that they become quite tight or quite loose. On this particular model here, quite loose. Other people have suffered where it's too tight and it sort of pulls in the motors together, and you can't quite get them to sort of move forward. And that's because you're printing this one part over and over again, 16 times on each side. So if there's ever so slightly a tolerance or an error in the printing, or maybe it's just a filament or the 3D printer, whatever that is, that it will multiply, it will amplify that error over the entire length of the track. So if you've got 16 of them, it'll be 16 times that error. So that's one of the things to bear in mind there, and I think that's why today it's quite good that we can actually get our hands on the original source. We can play around with it, we can maybe add a bit of a tolerance ourselves, and if you find that you are getting that tightness or slackness on the track, rather than printing the entire side again, you could print maybe 4 or 8 different sizes that have a slight different size to them. So one of the things that people have recommended on the various forums is, rather than tinkering with this design, you can just go into your slicing software such as Cura and just expand this by the sort of the y-axis. So just apply a very slight stretch to it. You don't want to apply too much, because then it won't fit around the wheel. It won't actually work the way it should do, where they sort of totally go around the wheel. So if it's too big, that won't work, and we'll get into that in a second. So that's what I just wanted to bring to your attention there. It's quite a common thing. It's an interesting facet of the design, the fact that we have 16 of these on here. They can actually be used, and 8 will fit round the entire wheel, and that's because there is an octagon inside here. You can just see the sort of faces on there. And we looked at that when we designed the wheels. I'll put a link to the wheels video up here for when this is played back. Okay, so as usual, I've got my little dimensions table. What I will do today, rather than typing those out, let's just directly model the thing, and then let's see how we go. Okay, so let's create a sketch. So what we're going to do first of all, something we've not done before on here, is we're going to derive this design from the wheel design that we've already created, and that will make sure that the track and the wheel are sort of in sync, so any changes we make to the wheel design will also be reflected in the track design. So what I'm going to do is I'm going to find our wheel, which was on my very poor file system, wheels tutorial, and there we go, that one there. So what I'm going to do is I'm going to do insert and insert derive. I'm going to choose my wheel tutorial, and then I'm just going to choose the octagonal profile. So just wait for that to load up. So in our sketches we've got here, we've got no, I've renamed these, so when we created them it's just the second one, and it's the one that has this octagonal design to it, because that's what we're going to use in a second to create our track. Okay, so that's now going to come across into our new design. We can close that data panel actually, and let's open up that sketch, and there is our octagon sketch. So what we'll now do, we'll create a new sketch, but I'll project through these dimensions because it's this octagonal profile that we're after. So let's create a new sketch. Let's create it on this face. Let's grab that P to project. Let's project just those two there, maybe that and that. Okay, and then let's just create a circle, C for circle, and let's do that to the outer rim. Let's create some construction lines, so L for line, X for construction. Let's lock it to that origin there, extrude it out there. We'll have another one following that line there as well. Okay, so what we're going to do is we're going to create our track on top here. So we'll use the circle tool again. So I'm just going to create a circle. I'm just going to do it somewhere on this line here. I'm going to create one somewhere on this line here as well. I'm going to make them both equal in size, and I'm then going to select them and make them so that they're not construction lines. Okay, let's get my measurements up here. So what I've got just to the side of the screen is I'm just looking at the tutorial and SMARS fan, and I'm just going to build along with the instructions that I've written there already. So the first one then is this wheel diameter side, this profile size here. We need to just dimension that, so D for dimension, and this is 3.8. And what we want to do is make that edge tangent with this edge here. So let's try that. So that's going to be tangent with that, oops, that point there. Did I quite get that right? Assuming no I didn't, let me just do that again. So I'm just going to click on that constraint, just delete it and try that again. So tangent that to that, there we go. And similar with this one, this just needs to be tangent also with that. Right. So let me just see why that's blue. That's because that is not linked to just make that so that that is coincident with that point there. Perfect. They both turn black. That's good. Okay, so I'm going to do a new line, and let's see. So what we want to do is create a line that joins the top section and the bottom section of these two circles. I'm just going to draw them out like that first of all, and then I need to use the tangent tool again. So make this point tangent with this. Make this point tangent with this. Let's pick the wrong part of it to be tangent with, so let me just get that a bit closer so that we can get it to estimate it properly. Right, let's try that again. Tangent with this. There we go. That's the one. So we can now select that end point, drag that out until you can feel it snap just there. And similar with this one, drag that out till it snaps in place. If it's not snapping, we can just make it coincident. There we go. So let's select that, make it, hit X to make it solid, and we're just going to do the same with the bottom line there. So that point there needs to be, that line there needs to be tangent with this wheel, and that line also needs to be tangent with this wheel. So now let's drag that out. Don't think that's quite worked, has it? Oh no, that's fine, it has worked. Okay, so let's just check that out. So that needs to be extended until it locks into place there. There we go. And then select it, hit X. So now that we've got our profile for the track. So just as a quick measure, I'm going to do a dimension from the inner point of these two circles, and it should be about 13.509, which it isn't. So I'm just checking to see why that is. So I think that's correct. Just checking to see. We also do need to have a circle in the middle from there, which is going to be our filament pivot point. So again, they just need to be equal. So that point and that point need to be equal. And we just need to dimension one of them to be 1.75. Now, because we need a bit of tolerance there, when we put in this filament through that hole, we want it to be a nice snug fit, but we might not want it to be exactly the same size as the filament, because that means it won't actually fit through. So rather than 1.75, I'm going to do 1.77. So I'm going to add in a 0.2 tolerance to that. So let's just go back to select, make them so that they're solid by hitting X, or we can go up there and deselect construction line. So what I wanted to do is just check why I've got a different dimension on my model on SMARS fan. So that's saying that's 13.509, and I think it's to do with this circular profile here. I'm curious to see, is that hitting the outside of the line? See, there's two. There's one which is brought in ever so slightly, because I think that's what should happen. So let's go and remove one of these just for a moment. Let's just move this up. It's got to be correct, because if it's not correct, the track won't fit properly. So it does need to be accurate. So let's just try making that tangent with this outside. And I'm interested to see what this measurement comes out as. So let's just do that dimension again, just so that we can have it there. It's going to complain about it being over constrained, but then put it in brackets just to tell us that that's what the actual measurement is. So let's do that, and then let's just move this one similarly. So we do need to correct that line there. That line needs to be tangential to that bottom section there. And we just need to get that to lock into place there. There we go. And we just need to do the same on here. So we just need to get rid of those two constraints and then reapply them. Okay. Okay, let's just move that wheel up. It's not a wheel, it's just a profile. Tangential to that edge there. And do we have the magic number? We do. So that's where I've made a mistake just then. These things happen. Okay, so now we just need to make sure that line there is still tangential. So let's just remove that point there. Make the line tangent to there. And then let's just extend it until it clicks into place. There we go. Perfect. Okay, so that is looking pretty similar to that. Okay, what I've done on this one as well, excuse me, I've just extended out a rectangle around there, because I use that later on when I'm trying to measure a sketch on the very top surface. So I'm just going to do that now just so that it helps us a bit later on. So let's just do a line. So L for line. Doesn't matter if it's not straight just yet, we can make that straight in a second. Sometimes I'll purposely draw them that I know that's not parallel line. Oops. Just because we can then make sure these things are correct. So I'm going to make that one perpendicular to this line and that one perpendicular to that line as well, so that they're now sort of perpendicular as we want them to be. I'm going to make that one tangent to the edge of there and that one tangent to the edge of there. That's interesting. Sort of bent in half there. Let's get rid of that part of the line. And I'm just going to extend out two of the lines as well from the edge of here. Just like that. And then that one there. And from that point to there. And then from this point to there. Okay, and what we can do now is just tidy these up just by locking these endpoints so that they join together. There we go. Still in trouble getting that one to do that. And that one there, perfect. That one doesn't seem to want to do that. Ah, it's because it's locked to the midpoint there, that's why. I was wondering why that couldn't move that one up and down. There we go. Nearly done, so that just needs to do that there, down to there, that to that line there, that to that line there. Let's just zoom in a bit again. Perfect. Okay. That bottom line is on the wrong part, so we just need that to be there. Perfect. Yep, that's good. Okay. So that is now the profile completed for the first part of the track. So let's have a look at that. There, right, so we're going to hit Q for push and pull. We're going to select the profile that we're interested in, which is that bit and that bit there. And we are going to pull it out by the depth of the wheel. If you remember what that was from the previous ones, it was 21 millimeters. I can see that because it just says there, depth 21. So now that we've done that, let's go to the top profile. So we're going to click on here, we're going to create a sketch on the very top. And this is where when we created those little rectangles, it'll help us draw out the next piece. So I'm going to hit P for project. I'm going to click on these parts just to bring everything in. Okay. Just want to make sure we don't need that bit there. There's a funny shadow. Oh, that's okay. Okay, so this one's quite straightforward. We just need to do a line down the midpoint as a guide for us. So I'm just hitting L and X to make it construction line. I'm going to remove the body now just so that we can concentrate on just what we're interested in. And we do need to get that top edge just here. So I'm just going to hit P for project. And we need to bring in that whole piece. So let's select the body. There we go. Perfect. Right. So now we can make that lock into place there. So let's have a line going across the very top. Let's just make that flat. And let's make that coincident with that top edge there. Don't seem to be able to quite get that edge there. Just going to go back into P for project, select the body. The body's visible. Okay, so can we lock into that there? So that needs to be coincident with that point there. Just can't get hold of that point. Okay, let's just forget about that for a minute. So essentially what we want to do is create a couple of rectangles, a couple of squares in fact, just a square at the top, a square at the bottom, and then a line across. So let's just create them. So I'm going to do R for rectangle. Let's make them solid. So I'm going to draw it out there. So that needs to be 5 by 5. 5 by 5. And I'm going to draw a construction line down the middle so that we can align these nicely. So now if we do the collinear constraint between that line and that line, that's interesting, it's not found the midpoint. So that line there, let's make this line go to the midpoint of that line. And then let's just bring that down, like so. Okay, we can bring that line down. Okay. I am having a lot of trouble with this one today. Do you know, I'm going to just start this sketch again. Let's just delete that. Finish the sketch, delete it, start again. I'm not happy with how that's going. Okay, so let's just bring back our top area. Let's create a new sketch on that surface. Let us hit P for project. We're going to select the body. We're going to select that body. It should bring in all the body. So now that looks much better. So now let's just draw some lines around that very edge so that we can use them to constrain things against. There we go. From there to there. Right, cooking with gas. X for construction line, just found the midpoint there, and I'm going to draw that there. So now we should be able to draw in our rectangles again, our squares, which are 5 by 5. So 5 by 5. And I'm going to select these and just make them solid just by hitting X when I've selected the line. So I just want a midpoint as well, like we did before, down to there. Okay, so now we can do the collinear constraint between the middle lines, like so, and a constraint between that top line and that top area there. Perfect. Phew, that took a bit of getting to. Right, so now we want to do one more square 5 by 5. And by 5. We want to do our mid point again. We want to make that collinear with our midpoint line or our center line, and then we just want that edge there to be collinear with that edge there. And then let's just make these so that they're solid by hitting X. Okay, we just need one last line which goes across from here. Let's do that one again, across from that point there to the edge. It does need to be square on, and similar from there to there, and let's make them both solid. X, and let's see if we can get them to just snap into place there. Okay, that is it. So we can finish that sketch. We can have a look at it there. And now we just need to extrude, cut those bits of the profile that we don't want. So I'm just going to select them, press Q to push pull. I'm just going to slam that down there and then cut all the way through. Okay, it's looking a bit more like our design now, isn't it? Look at that. I'm intrigued why that bottom edge isn't correct. you can see there's a bit of a line there. There shouldn't be that weird thing happening there. I'm just going to go back into our first sketch and fix that up. I think that what that's to do with is when we did our extrude in the profile, it's included some bits here. So what we'll do, we'll make these construction lines so that they don't get caught up. And I think that one there needs to be construction line 2. Let's finish that. Let's go back to our extruding part there. There we go. So it's missing that tiny bit of the profile there. And I think the same on, oops, that area just there. So it's just that bit that it's missing, and it shouldn't have that bit there. Let's have a look how that looks now. Of course, it's brought in that entire loop, which we didn't want. Let's go back there and unselect that. Still missing that little area there, isn't it? Oh, good grief. Just that little bit, just there. Just going to go back into that sketch there and just get rid of that line there. So that is a construction, that is a construction. Finish that sketch, go into there, let's just select our profile again, so we want that, we want that, we want that. Okay, nearly done. And just that little bit, just there. That looks good. Okay, fix that up. Right, so what we need to do now is just these square edges just need a nice fillet applying to them. So let's just do that. So let's go to our modify and fillet tool. Let's select that edge, that edge, that edge, and that edge there. And let's apply a 1.9 fillet on there. It's looking like a piece of track. Okay, so now what we need to do is cut out this diamond profile that we have there, right through there, and that's the bit that aligns with the diamonds on the wheels themselves. So they need to sort of lock into place, and that's what makes them actually have some purchase. So let's click on that top one. Let's create a new profile. And then let's just sketch out the diamond. So I'm just going to do the center point again. Let's L and X. Let's lock into place there. Let's try to move that profile about a bit. There we go. Okay. It doesn't have to be perfect. There we go. And let's sketch out the diamond. So if you remember from the wheel tutorial, which I'll put a link to in the cards thing, the diamond was 5.5 millimeters. So again, 5.5 millimeters, that's what we're going to create. So let's just do that. So let's sketch out a diamond. So L, let's just roughly sketch this out. Doesn't have to be perfect. We can constrain everything to make it perfect. So that needs to be equal to that. Let's make that one 5.5, and let's make these perpendicular, and let's lock that point to the center line, that point to the center line, and then now you would think that that would lock to there, but it doesn't. It locks to the center of the track, which is this from the origin. So if we just draw out a construction line from the origin, it'll make it a bit easier for us to lock that to there. So we just need to get that point and just lock it in place. So there's a tiny piece of the diamond which is sticking out there, and if you do look at a piece of track, you can see that it's missing part of the diamond as well. Okay, so let's just finish that sketch. Let's go to extrude that profile. So select it, Q, cut it through, and we're going to do this distance as all. Okay, there we go. And now we are going to create the track itself. So there's like looks like there's two pieces there, but if you look on the profile there, these bits that sort of stick out, that's the bit that actually grips the surface. So we just need to create that. So we're going to click on that surface again. We are going to draw out rectangle. So let's do a center point rectangle, and let's just draw that out roughly. Let's do our center line again so that we've got something to snap it to. So that point needs to snap in place to there, and this is 3.5. Oops, that's wrong. Not that way. 3.5 that way, and we just need to make that lock in place again. So that needs to be coincident with the line. Okay, and we will make that top line collinear with that line there, and then for the length of it we'll just make it collinear with these lines here. Just need to pick one side because it's the center point. So there we go. Okay, so that's our track profile. We can now extrude that up. So finish the sketch. Let's select both parts. Q for push pull, and we're going to pull it up by 1.75. Okay, we just need to apply some chamfers to this. Now on the official design, I don't know if you've ever looked at this, one side does have, you can see that there, one side is left flat and the other one has chamfers on both sides. I assume that's so that it has something to grip on, that flat side gives it something to sort of dig into, particularly on carpet or if it's outside on sort of dirt. So that's what it is. Let's select them, let's apply a chamfer, and let's apply a chamfer of 1.75. Let's try that. So that'll go straight through, and we can also just extend that out as well to the other side. So we can do it like that if we want to keep one of the sides flat. So that's more like the original design. So you've got that nice area where it can grip. Okay. So then the last thing that we need to do, because we made this the width of the whole wheel, we need it to actually sit in between these two rims. So we just grab a piece, put that over the top. It's sitting between the rims, and that helps it lock into place side to side. So to do that, we just need to trim off 1 millimeter of each side. So we can do that by just selecting the top profile again, creating a sketch, clicking on that flat surface there, and create some rectangle. I'm going to project in the body again, and let's create some rectangles from that top edge there that are going to be 1 millimeter. Oops. D for diameter, 1 millimeter, and R for rectangle from that point there, drag down, D for diameter, 1 millimeter. Okay, I'm not too bothered about how long these are, as long as they're just longer than this part that they're going to cut through. but OCD says let's constrain these, so I'm just thinking let's make them collinear with this line here. So that line there and that line there. Okay, so now we can just apply a cut to these, an extrude cut, and we have to extrude up and down because we're going down through that and up through this little triangle area. So let's just select all parts of the profile we're going to use to cut. Okay, oops. Tell you what, let's just do Q. Now we can select them a bit easier. Okay, and we're going to do symmetrical. I'm going to say distance all, and we're cutting it. Okay, we have some track. So let's have a look what this looks like in our rendering. So let's drop on some colour. So what I'm going to apply here is some black matte plastic. So plastic matte. Let's see what we've got available. Yeah, black. Okay, and let's have a look at that. That's looking pretty good. So on the bottom of the tutorial there, you can see some interesting profiles. So this here is how those calculations work. So you can see projected from there, there's our profile, and these sort of sit flush on the sides of that circle on the octagon. And because it's an octagon, there's 8 pieces, so these 2 pieces sort of flip down there, them 2 flip up there to make an entire circle. So if you just get one from here, so if you've got a SMARS, you can use the same 8 pieces either to create an entire caterpillar track or just to surround in each individual wheel. So that's what they look like there, and there's a more rendered version. You can see them going all the way around, and there's a sort of hero shot of our favourite SMARS robot. Okay, so that is it for the tracks today. Is there any questions from the chat? I shall just give it a moment for people to catch up on that. I think there's about a 30-second delay between me speaking and you hearing it. So I'll just wait for that to come through if there are any questions. You can see on here we've got all the different measurements for each of the things that you're interested in, and there is the table as well, which has got all the key measurements in there. And we've got the note as well. I have included as well a PDF so that you can download the sort of sketch of the track. If you prefer to sort of use this, you could print it out or have it on a separate screen, and you can see all the key measurements for each of the things that we're interested in. And that should help when you're constructing it yourself. So what we're looking at on Friday is the motor holder, which is the very last part of the wheeled SMARS design. So that's my favourite one just to hand there. So that's these yellow sections that are in here that actually hold the motors in place and stop them from sort of falling out. So it's a pressure fit, and they also have these little lugs to help keep the battery in place if using the 9-volt battery. So that's what we're going to be going through on Friday, and you can see there we've already got the instructions ready to go for that. So please join me for that one on Friday as well. Be interesting to see if there's any questions on that one. And then after these, we'll look at the SMARS quad, creating all the different components for the SMARS quad. One of the things I'm really excited about on that is the servo holder. We can use that in all kinds of new designs, so I'm really keen to sort of model that out, and then we can start playing with that. So one of the things I've got in mind is maybe having like a JCB arm on the top of here, a digger arm, so it can scoop and things and be articulated, and we can use maybe 2 or 3 different servos to drive that. So that's what I'll be looking at from a modelling perspective next. I'm also looking at doing some electronics videos. So what we'll be looking at there is all the different options that you have for shields. So I've got one of the Arduino shields on this one. What else have we got to hand here? We have the Node MCU motor shield on this one. I've got quite a few other ones as well, so we'll be looking at doing a review of them, seeing what the pros and cons are, what the different pinouts are, and so on. And we'll also be looking at doing some coding as well, so actually using the Arduino IDE, playing around with that. We're looking at other boards as well, like the Node MCU, looking at the microbit. I've got a few of them and a few boards that we can use to some shields for the microbit as well as the Node MCU. And we're looking at some other things as well. So I see this week Kevin Thomas has been experimenting with a camera, and he's used an ESP32 camera. These are very cheap to buy. They're about seven UK pounds, about $10 US, something like that, shipped, and they can run everything. All they don't have is the motor driver. So you can get small circuits for that as well. So we'll look at reviewing some of them when we get round to that. But I hope these live streams are of value to everyone. If you do find them of value, please sort of like and subscribe and comment on the video. And if you subscribe, click the little bell icon and set that to all to make sure that whenever I post a new video, you get an update on that. And please visit the website as well. You know, it really helps me out if people look at that. And you know, if there's anything any useful to you from the shop point of view, we've got all the different components in there that you might want to use. So have a look through the shop. We've got all the common components, things like the shields, the batteries, the motors, all the different parts that you need. And for the SMARS quad, I've taken the Raspberry Pi Zero and used that with some Python code to make that, bring that to life. So I hope this was great. Like I said, please like and subscribe and comment on the video. I'll just have a quick look on the chat. I think we've got a question there from Samo. So the PDF was a really cool idea. The wheels on the track, the same both models, original and V4. Yeah. So the original wheels. This is one of the original wheel designs. I love these. I thought they were really inspiring design. I like the width of them, the fact you can use the track. The weight of them makes the SMARS grip the road really well, grip the surface really well. The fact you can then put a track on them and that they can drive that. I thought that was really good. And I did think, you know, I printed so many of these wheels out now, I was getting a bit bored of this design, so I was thinking, wouldn't it be great if you could sort of remove that inner section and design your own inner wheels. So that's what this, I'll put a link in the video to the card for that. The wheels video showed you how to create your own wheels, do your own different designs. So yes, the measurements that I took for this new wheel that I've designed is from the original design, so they should work fine. If they don't, please let me know and we can have a video looking at that. Tom says thanks a lot for the video. No problem, Tom. Yeah, so if anybody's got any other ideas, anything that they would like me to look at, talk about, anything to do with robotics at all, we can look at things like the Otto as well, the Otto DIY that Camilleo's created. We can look at the OpenCat. I've created one of those as well. Basically anything to do with robots. I've even got an InMove in the loft that I've been slowly putting together. It was one of the first big prints that I did. And I got kind of a bit overwhelmed by the amount of things I had to learn on that, so that's why I sort of went back to something more simple like the SMARS, because it meant that I could learn at my own pace. And as I showed on that diagram I shared earlier in the week, let's see if I can quickly find it on here. So that was, I don't think I've got it to hand. Let's just open up Finder and find that. And this is the sort of intersection of the three disciplines that you need to have to be a roboteer, to be somebody who's good at creating robots. So let's go on to here. Let's find the Venn diagram. Can never find things when you want them. So that was on YouTube Assets. There we go. Venn diagram. Perfect. So let's bring that across there. Let's just stretch this down a bit so we can see it. So yeah, you know, we're looking at Fusion 360 at the moment. We're looking at how you can create different parts from the original SMARS in Fusion so that we can then go on to modify them. We can look at Cura and how to slice things and all the correct settings for that. 3D printing, all the kinds of pros and cons and tips and tricks for 3D printing. I use Octoprint to drive my printer. I've got a little Raspberry Pi connected to it. It's just off to my left here. And creating STLs as well. So one of the great things in Fusion, once you've created a body like this, you can just right click on that body. He says I'm in the wrong window there. Right click, save as STL, and that will then create an STL file. We can just save that out. We can just create that in, let's go to our tracks tutorial, and let's call this one tracks STL. We can then fire up something like Cura or Simplify 3D. Let's go for Cura. Let's load that in there. Got a message there from YouTube Studio saying I'm not getting enough video to maintain smooth streaming, so there might be some buffering. So apologies for that. I don't know what on earth is going on today with YouTube. I did check out my stream health and my broadband speed. There's no issues there, so I've no idea what's going on with that. There we go. Ultimate Cura. So let's just load that up. Just want to show you how quickly we can create something as a model from Fusion from scratch, and then how we can then just load that into Cura, slice it, and then begin printing. I'll not start printing because it will take hours to do that. Okay, so just got Cura firing up there now. Okay, so let's just bring this into view. So we can now just load up the STL that we've just created, which is in our tracks. Okay, and we called it tracks.stl. There it is, today at 7:45. And there we go. You can see it's just on the bed there. So what we probably need to do there, because we created it at an angle, we'll probably just need to make that surface on the bottom flat with the bed. So if we just select it and then just do align surface with bed, there we go, that's sat nicely now. And we could just create that. We could just say we want to have how many of them. Multiply model, we need 32, so we could just say we want 32 of them. Boom, there we go, a bed full of tracks. Now I don't know if it's just where I'm printing and the location in the house where there's a bit of a breeze maybe coming through. But when I try and print 32 off like that on the bed, I'll find lots of issues where ones on the outer edge will sort of warp and not print correctly. The ones in the middle are fine, so I never tend to print 32 at a time. I might do 8 at a time. Never quite sure why that is, so that's one of the things I need to look at. Okay, so I'm just going to stop it from doing the slicing there. It's going to come out of that. So that's how we can go from modelling something from scratch, just from some bare instructions, from a PDF, and then creating an STL file that we can optimize ourselves. So I hope you found this useful. Please join me on Friday for the next one, and have a good evening. Thanks everybody.